Okay, hello everybody, Cozy Azeroth here, and today I'm going to do Part 9, Chapter 9 of the Texas Instruments TI-99 4A Learning Basic, a.k.a. Teach Yourself Basic tutorial. I've done chapters 1 through 8. You can find those on my YouTube channel, either under Cozy Azeroth or by my actual name, Zachary Fruling. You can also catch future streams on my Twitch channel, which is Cozy Azeroth. I'm broadcasting this on Twitch, but it's going to be on YouTube before you know it, so you may be watching this in either location. Without further ado, let's dive in. So we're going to go to TI Basic. I've got the disk image for this chapter saved to disk 2, so we're going to type old dsk2 dot chapter 9. I can't believe we're in chapter 9 already, out of 10 chapters. And I have not looked at this one since I was a kid, so I don't really know what to expect. I know it's about data handling, that's all I know. It'll take a minute for the program to load into memory, as if it is reading it from the disk. This is an emulator. I'm using the Classic 99 emulator, which I highly recommend. I am using an older version of Classic 99 just because I haven't installed the newer version of it. I need to do that at some point. It has some features that I want, like being able to take a program and basically have a save state that you can run as an executable as a Windows program, which is awesome. I asked for that feature and it got built, so I'm very pleased about that. I didn't realize that, so I've got to get up to speed on the newest version. So we got the program loaded into memory. Run chapter 9. I don't really know what to expect here, so let's check it out together. It'll take a minute for it to parse the entire program, essentially. Data handling. Sexy. Learning Basic. Chapter 9. I'll have to come back and get some screenshots for the YouTube thumbnail. I'll do that after, though. I love the graphics on this system. I say that every time, but I really do. I'm still enamored with it after all these years. Formative in terms of my computer and frankly gaming aesthetic. The goal of computer work is efficient processing of data. I don't know about that. I think there's some things that are done purely gratuitously and not for efficiency. This chapter is about storing and retrieving programs and data from cassette tapes and disks. Okay. Disks and tapes have different features and different instructions in, quote, basic. I don't know why basic gets quotes. We will learn about the following statements. Save, old, open, close, print, pound, let's call it pound, input pound, although it's probably a hashtag now, print hashtag, input hashtag, but back then it was probably pound. It's like a pound sign on a phone. Young people don't even know that that was once called a pound sign. It's a hashtag to everyone now. Delete and restore, okay? What do you want to know about, discs or cassettes? So we might have to run this a couple times. Let's learn about discs first. Although when I was a kid, I just had the a cassette player. I didn't have a disk drive for the TI-99 4A. Disk operations. The first thing we will talk about is how you can save a program that you have written. You do it with the save command. The quote save command is used to record your program either on a disk or a cassette tape. You can have up to 3 disk drives. They are known as DSK1, DSK2, and DSK3. If you have a program that you want to save, you must give it a name. Program names may be up to 10 characters long. They must start with a letter of the alphabet. Suppose that you have a program that you want to save, and there's a typo. You want to call the program Fred. How did a typo like that end up in the finished product? You want to call the program Fred. The statement save dsk1.fred would save the program on disk drive 1. The program will be saved with the name Fred. Later, when you want to read in the program named Fred, you would do it with an old statement, as in it's an old program. The statement old dsk1.fred would read the program named Fred into the computer. To run the program, you would just enter run. Press enter. You can also remove a program from a disk. If you want to remove a program named Fred from disk 1, you would enter delete, and then in quotes, dsk1.fred. You must use the quote marks. In addition to storing programs, you can also store and retrieve data. Data is stored in things called data files. You tell the computer that you want to work with a particular data file with an open statement. You tell it that you are finished working with a particular file with a close statement. Let's do a data handling program to enter and retrieve data. Disk data handling can be done in two ways: putting data sequentially on the disk and putting data to specified locations on the disk, relative files. Okay, that seems clear. Sequential data handling is just like cassette data handling. The difference is that disk data files can be named. For example, if you wanted to call a data file mouse, you would use dsk1.mouse, as in the file name, instead of cs1 for tape. Since tape data handling is so similar to disk sequential data handling, perhaps we should start with a discussion of tape handling. Would you like to study tape handling? Yes, I would. Okay, this is a program to put data on tape. Open tells the computer that we want to work with a data file on tape. Now, this is something I've never done. I never wrote a program that required save data, and I should try that sometime. Maybe I'll mess around in Classic 99 and see if I can, write some interesting program that requires the program to save and retrieve the data onto a virtual disk drive. Okay, this is a program to put data on tape. Open tells the computer that we want to work with a data file on tape. Okay. Ooh, didn't like my enter press there. Number 1 is the number of the file. This number will be used in the print pound and close pound statements. CS1 tells the computer the file is on cassette 1. Output says that you want to write data onto the tape. You need the word fixed when you are using cassettes. Press enter. A number after fixed sets the record length. If there is no number, the length is set to 60. Okay. For disks, we would use dsk1.filename instead of cs1 in line 10. File name can be any name you want, up to 10 characters. dsk1.wolfdata, for example. I love it, wolf data. Quote fixed may be used with disks. If no number follows fixed, the record length is set to 80. Statement 20 is a normal input statement. Print pound 1, or print number 1, tells the computer to print the data onto file number 1, cassette 1. Press enter. It's interesting to see the legacy use of the word print, even as BASIC evolved to the point where things are not being printed to, paper ticker tapes as they used to, or printed to punch cards, but printed in some other way in the sense of an output. So print became in BASIC this generic phrase for an output. Print to the screen, print to the disk, print to the cassette tape, print to the screen, so on and so forth. Generic term. And kind of a holdover. It's easy to see why later programming languages did away with the term. Well, not really, actually. I mean, there are still print statements even in modern languages. In fact, I'm working on a retro video game in Pico 8 using the Lua programming language, and it has print statements as well. So it never really went away. changed my mind about that. The program will fail if you attempt to print number. I'm not sure how they intended you to pronounce that. Print pound, print number, print pound data, which is longer than the specified record length. Okay. How do you know the record length? That's a good question. It's not very clear about that. Statement 40 is a way to end the input of data after the XXX record has been written. Subversive. What are they putting on those tapes? What kind of programs have you been writing? 60, close number 1. Close number 1, or close pound 1, says we are finished working with file number 1. This is how we put data on tape. Let's see now how we read data from tape. Press enter. We change output into input. Input means that we are reading from the tape. Okay. We change the input into an input pound statement, or input number. Input pound reads data from the tape, not the keyboard. Got it. I never used these when I was a kid. It's a part of TI Basic that is, it's not that I didn't get that far. I certainly went through this tutorial because I wanted to get to chapter 10, which just covers all the cool stuff, graphics and colors and whatnot. But so I almost certainly watched this one and then skipped over it, and it didn't sink in at all when I was a kid. Do you want to return to disk handling? Oh, we didn't read what happens here. We change print pound into a normal print statement, and we are finished. Do you want to return to disk handling? Yes. By the way, the restore command that you learned for data statements also works for data on disks. Quote, restore would cause the next item of data read to be read from the beginning of the data file. Only for sequential data. This also works for tapes. In this case, the screen will prompt when to rewind the tape. In addition to sequential data handling, disks can also be used for relative data handling. This means that we can store data in little blocks on the disk, and we can make changes to any individual block. Let's do a program to demonstrate relative file usage. Let's do that. Okay, let's see what we got here. 10, open number 2, dsk1.foxface, relative 50. Isn't Foxface a character in the Hunger Games? I think briefly on screen, but also in the books. One of the other players that gets killed. Okay, 20. Input record number, comma data, rn d string 30 print number 2 rec rn colon c string 40 input record number. That's that record number. Yeah, not record number, record number. Hello, good morning. That's rn 50 input number 2 rec, get the same construction here, rn colon c string 60 print c string 70 close number 2. Statement 10 is our usual open statement except for 2 things. Relative 50. This means that we are making the file a random access or relative file. The number of entries in the file is started at 50. Okay. Also, we have not specified input or output. For disks, this means that we are in update mode. Update means that we are in both input and output modes. Okay. You know, I think this tutorial is useful on the one hand. It's teaching you the syntax here, but it's not super useful at explaining some of the key concepts. I get the distinct impression that this This particular tutorial was written for people that already had something resembling a working knowledge of data structures and input in various types of inputs and outputs. This is not crystal clear. Whereas almost, I think all the other tutorials except Chapter 9 here have been crystal clear. Statement 20 is a normal input statement used to key in a record number and data. Okay. REC, RN in this statement means print the data into the record block RN. RN must be below 50. This is how you put data into blocks on the disk. Okay, press enter. Like, if you're brand new to computers and you don't really know how disks work, blocks on a disk, you're like, what does that mean? So I think, like I was just saying, unlike the previous tutorials, I think Chapter 9 here is failing in terms of clarity for the absolute newcomer. Okay, statements 40, 50, and 60 show how to get a random data block from the disk. In this statement, the data RN is read from the disk. That's all there is to it, as if that were crystal clear. I'm not usually critical of the TI. TI is an amazing system. These tutorials are amazing. I learned a lot from them, but this one is not crystal clear. There are more advanced ways of handling data, but once you are used to these easy methods, you can use your basic manual to learn the more advanced, quote, tricks of the trade. Important warning. Should have put that in red, right? While you are handling data with disks, you must not turn off the computer. If you do, you could lose all of the data on your disk. If you must stop the computer, do the following. Stop the computer with Shift-C. Enter by. This closes all open files. Now you can turn your computer off. Well, I guess you know enough about data now. And now that you do, we have reached the end of Chapter 9. There are always lots of data. That's cute. That's adorable. I love the colorfulness of the system. Okay, I want to run it one more time because if you remember, I think we probably covered everything because it gave us a chance to see how the difference between discs and cassettes, but I want to rerun the program and choose option 2 and just make sure we haven't missed anything. So it'll take a minute for it to parse the program and run it again. And we'll see if we end up with essentially the same content we already saw or if something new. Data handling. Cryptic. Even the splash screen looks cryptic compared to all the previous splash screens. This is definitely advanced TI basic. Not the kind of thing I would have messed with when I was 6 years old. So we'll read it again. I don't mind reading it again. The goal of computer work is efficient processing of data. I don't think that's true. It's underappreciated how computers are used for creative purposes. Okay, this chapter is about storing and retrieving programs and data from cassette tapes and disks. Disks and tapes have different features and different instructions in, quote, basic. We will learn about the following statements: save, old, open, close, print number, or print pound, input pound, depending on how you want to pronounce it, delete, and restore. What do you want to know about, disks or cassettes? So we chose one before. Let's choose cassettes. Now I think this is probably going to cover everything we've already covered, but let's check it out. Cassette operations. The first thing we want to talk about is how you can save a program that you have written. You do it with the save command. The save command is used to record your program either on a disk or a cassette tape. Okay. Save CS1 will record the program on cassette recorder number 1. Of course, when I was a kid, I only had one cassette recorder. I guess I always kind of wondered about people that had dual cassette recorders on their TI-99. Like, what fancy magics were they using? Similarly, save CS2 would save your program on cassette recorder 2 if you have a second recorder. When you use the save command, the screen will prompt you when to turn the recorder on. I guess I wouldn't even know how to hook up a second recorder to the TI-99. Never really looked. When you want to use a program that you previously saved, use the old statement, as in it's an old program. Only cassette recorder CS1 can be used with old if you enter old CS1, the program on the tape will be read into the computer. The screen will tell you when to turn on the recorder. To run the program, you would just enter run. In addition to storing programs, you can also store and retrieve data. Data is stored in things called data files. You tell the computer that you want to work with a particular data file with an open statement. You tell it that you are finished working with a particular file with a close statement. Let's do a data handling program to enter and retrieve data. And I think we've already done this, but let's see if there's anything new here. Okay, open. This is a program to put data on tape. Open tells the computer that we want to work with a data file on tape. Number one. Number one, or pound one, number one. Number one is the number of the file. This number will be used in print number or print pound and close number or close pound statements. CS1 tells the computer the file is on cassette 1. Seems clear. Output. Output says that you want to write data onto the tape. Outputting from the computer to the tape. Makes sense? Fixed. You need the word fixed when you are using cassettes. And they don't really explain why. A number after fixed sets the record length. If there is no number, the length is set to 60. Again, what I'm wanting to know is why. Why 60? Why do you have to use fixed? Give me some little more explanation would have been helpful here. I mean, they're actual answers, and I probably know them, but beyond the scope. Statement 20 is a normal input statement. Print number 1, or print pound 1. Print number 1 tells the computer to print the data onto file number 1. Print in the sense of output. Again, it's a weird choice. Like if I were writing this language from scratch, I probably would have said output number 1, like output it to number 1, as opposed to print. But again, so it's a holdover from early computer days. The program will fail if you attempt to print number data, which is longer than the specified record length. Okay. Statement 40 is a way to end the input of data after the XXX record has been written. Those kinds of programs. Save those. $60, close number 1, or close pound 1. Close number 1 says we are finished working with file number 1. This is how we put data on tape. Let's see now how we read data from tape. Input as opposed to output. We change output into input. Input means that we are reading from the tape. Inputting data to the computer. Got it. We change the input into an input number statement. Input number reads data from the tape, or input pound. It's called input number, not the keyboard. We change print number into a normal print statement. And we are finished. There are more advanced ways of handling data, but once you're used to these easy methods, you can use your basic manual to learn the more advanced, quote, tricks of the trade. Important warning. While you are handling data with disks, you must not turn off the computer. If you do, you could lose all of the data on your disk. If you must stop the computer, do the following. Stop the computer with Shift-C, which we figured out was Alt-4 in this emulator. And maybe on the, frankly, I don't remember. I've got a box here with an old TI-99. Maybe I'll boot it up, but I noticed that Shift-C doesn't seem to work in this emulator, and I suspect that these tutorials were written for the TI-99 4, not the TI-99 4A, and the 4A has function keys, so it's like function 4, which is Alt-4 on my regular computer keyboard now to close the program. But I don't think there were function keys on the 99 4, so I think that's why it's Shift-C in this tutorial, but actually on the 99 4A it was function 4. Okay, enter by. This closes all open files. You can now turn your computer off. Well, I guess you know enough about data now, and now that you do, we have reached the end of Chapter 9. There are always lots of data. Data, of course, is plural. All right. Like we've done with all of the other chapters, let's list out the program and see if there's anything that jumps out. I suspect probably not, but we'll just kind of let it run and see if there's any commands here that really jump out at us. As usual, it's subroutines and subroutines and subroutines and subroutines. These are the graphic statements that make up the splash screen, I think. I don't see anything that's jumping out at me that we didn't really see in other tutorials. Of course, these are just tutorials, right? Yeah, I need to probably spend a little time playing around with Classic 99 and work on some sort of program that requires me to write data to the disk or to the virtual cassette and retrieve it. See if I can learn this little nook and cranny of TI Basic that I never learned back in the day. I'm also, while this is printing, I'm also listening to the screen. I'm also thinking about going through the two manuals, the beginner's basic, and then the TI basic reference guide, and just going through one program at a time, just to kind of for documentation purposes, but also to kind of refamiliarize myself with TI basic and what it's like to type programs in and create programs from scratch and just run through all the tutorials one at a time. The sample programs, I mean. I used to like the graphics match in the reference guide. That was my favorite type-in program from those manuals. Also remember Mr. Bojangles, the little guy that would dance on the screen. Okay, well there we go. That was Chapter 9 of Learning Basic, a.k.a. Teach Yourself Basic for the Texas Instruments TI-99 4A home computer. Like I said at the beginning, be sure to check my YouTube channel. It's either Cozy Azeroth or Zachary Fruling. You can find it under either one of those searches. And you'll find chapters 1 through 8 and very soon 1 through 9 once I get this uploaded to YouTube. And tune in for the final chapter, Chapter 10, on Twitch if you happen to catch me live, and eventually also on my YouTube channel once I get that far in the next couple of days once I get that far. Hope everyone's doing well, and happy computing. See you next time.